By now, you should have a good idea of all of the tables that you'll need to store your data, as well as all the individual fields or columns that will be in those tables, including the primary keys. Now comes the process of adding additional tables and fields that will be required by the DBMS to do its job efficiently. This is a process called normalization. Normalization is a series of rules that your database's table structure must pass in order to be considered a good relational design. The individual rules are called normal forms, and they must be tested in order, like passing through a series of gates or checkpoints. In other words, you can't satisfy the requirements of the second normal form without first satisfying the requirements of the first normal form. Now, you might have actually accomplished some of these checks earlier in the process without realizing it. There are multiple ways to identify the issues that we're about to look for. But it's always a good idea to go through a formal normalization process to make sure that nothing slipped through the cracks. So what are the rules, and how can we be sure that our tables satisfy each normal form? Let's take them in order. First normal form, or what is sometimes abbreviated as 1NF, requires that all fields only include a single piece of data. Here, we're looking to remove what are called multi-valued fields from our tables. Typically, these show up as comma-separated lists of values that are all stored in a single cell. In a hospital database, this might look like a list of medications that a patient is currently taking, or in a products table, it might be a list of features or benefits. Here we have a table describing the various tours offered by the Explore California Tour Company. One of the things that we want to keep track of are the keywords that people are likely to search by, so they will match up with the appropriate tour. While all of the information is there, can you quickly find all of the tours that feature camping? You have to scan through all of the keywords in order to do it, which isn't a very efficient design. We could break these out into individual columns, but this gets cumbersome. How many columns would you need? 3? 10? There really isn't a good way to plan a table like this, and it's also just not a good option. Instead, the solution is to break out the keywords into separate tables and make use of the primary key field we identified in the last movie to relate each individual keyword back to the parent tour table. In this way, we can use the primary key to find all of the associated keywords for a particular tour. For instance, Big Sur Retreat is tour ID number 1, and if I go to the keyword table, I can quickly see that it is associated with hiking, national parks, and Big Sur. As a secondary advantage to this setup, you'll notice that if we need to add a fourth keyword to Big Sur Retreat, say picnicking, we don't need to add a column to our table. It simply gets added as a new record in the keyword table. That's just one example of how a multi-valued field might try and sneak its way into your database, but you'll see this pattern all over the place if you're not careful. Consider a table that is storing transaction data or invoices. Each invoice might be for several different products, and each product is going to have a different quantity purchased. In a spreadsheet, you might just place everything together like this. But in a database, this represents the dreaded multi-valued field approach to storing data, which doesn't pass the requirements of first normal form. The fix is the same as before, however. Simply remove the offending columns, in this case the product name and quantity columns from the transaction table, and place them in a new table with a copy of the original invoice number. We can create a composite primary key for this table to ensure that each invoice only has one line 1 and one line 2 and so on. To do this, we'll simply designate a combination of the invoice number and the line item number as the unique identifier for each record. Now we can use the invoice number to look up all of the items that appeared on each invoice without having to stuff them all into a single line. So go through all of your tables and make sure that they won't be storing any multi-valued data. Create additional tables where necessary, and remember to link them together using the primary and foreign key fields. Once that's done, congratulations, your database now meets the requirements of first normal form, and it's ready to move on to the next step.